Hello and welcome to the Z Hut. Today we're going to take a look at how you can build your own Bluetooth controlled garage door opener. Now what we'll do first is we'll take a look at the circuit real quick. Then we'll go over and take a look at the app and how to use it. And then we'll go over onto the computer and I'll show you how you can build this app if you want to customize your own. Otherwise, the app I have written for controlling this is available for free. And if you look below, in the description below, you'll find a link to the website and you can download the app there for Android devices. Currently, I don't have one for iPhone, but I do have this app for Android. And it'll work on any Android phone or tablet that has Bluetooth in it. So let's just get down to going over the circuit here. And well, I haven't put it in a box yet because, of course, to do this tutorial, I wanted to show it to you. But once I get the box made to put this in, I'll take some pictures of that, and I'll probably shoot another video too of it in use in the garage. But in this tutorial, this video, I'm just going to go over how it all works and show you. So to get started, well, I've got my power source here. And right now I'm just powering with wall wart, and I'll plug that in when we get to the app. But when I put this in a box, I'm going to use an old 5-volt cell phone charger to run this because they don't draw many amps at all. And it'll work perfect with this. So that'll be being replaced, but for now I'm just using a wall wart to demonstrate the use of it. Otherwise, in the schematic, which will be on the website, it'll show you how to connect it to your Arduino microcontroller. So next then, well, we have our Arduino microcontroller. Now I'm using Nano so I can keep this small. I'm going to actually solder this onto a little breadboard, and it'll be quite smaller, but just for the tutorial I got it on a breadboard so you can see it easier. And you can also use an Uno or Pro Mini or Micro. Any of the Arduino microcontrollers will work for doing this. The next we have our Bluetooth module. This is an HC06. And we are running that through a logic level converter. Now these are real cheap. Lots of people use a voltage divider to do this because the HC06 is 3.3 volt logic and the Arduino board is 5 volt logic. And if you run the 5 volt logic straight into the Bluetooth module, you will destroy it. It might work, for a little while, but we're talking like maybe an hour at most if you're extremely lucky, and then it'll fry and quit working. And these little logic level converters, you can get these depending how many of them you buy. If you buy just one, you're talking around $1, but if you buy a bunch, you can get them down to like 50 cents a piece. And I ordered like 10 of them when I got these. And this is just a 2-channel. That's all you need because there's just the TX and RX. The voltage of the HC06 surprisingly has to be between 3.6 and 6 volts. So the power that goes to power the VC in, the VCC, has to hook to the Arduino's 5 volt power rail. Otherwise, everything else, the TX and RX, runs through the logic level converter. Then next, we have our relay, and this is what controls the door. And I have this run in, and it's on digital pin 5, I think, is the one connecting the relay. And when we get to the Arduino sketch, I will go through all the pins assignments. Now also, you see I have this button and it's connected to the same 2 wires, and this goes to my garage door opener. And these 2 are hooked in the same way. That way, if the power's off on this, and I'm also going to be putting, when I hook that 5 volts up, I've got a little toggle switch, so if I'm going out of town or I'm at home at night and I'm not going to be, needing the Bluetooth, I can turn it off. But I can still walk in my garage door, push this button, and this is just a doorbell button. I got my garage door opener used, and it didn't come with any of that, and they wanted like an outrageous amount of money for the stupid button. And all it is just a contact push button, and this garage door, or excuse me, doorbell button was under $2 at my local hardware store. Works perfect for this, perfect. Other than that, there isn't really anything else to go over on the circuit. And I will have the circuit on the website. And even if you're a beginner, this is easy to put together. This is not very complicated at all. So what we'll do next here, actually, how can I arrange this so we can see everything? There we go, that ought to work. All right, I'll power the tablet up. And let me grab my wall wart to plug this in. Alright. There we go. Now we got our Arduino board powered up. Alright, let me get the app opened up here. Alright, this is what it looks like when you first open the screen. It just has a Bluetooth connect button. And also on my next couple of videos, I'm going to be going over some more advanced stuff to do with this, like adding RFID card reader in association with this. And also I'm going to be doing a video here, maybe even later today, on how to set your apps up to when you launch the app, instead of having to manually go through and connect to your Bluetooth device, you will automatically do it, and that will be handy. So with the app, first we just push connect, then we choose our Bluetooth device. It'll take just a moment here, and you heard I also have audio on here. It also tells you it's connected. Then we have the door control button, and you push it once. You can see the relay clicks off and on. I got it set for about 1/4 of a second because it just has to click off and on real quick. And you know, you push it one time, it'll open the door. You push it again, it'll close the door. If the door is in the middle of opening or closing, you push it and it'll stop the door right there. That's all there is to this. I mean, this is pretty simple. And when we get over to the code on the MIT App Inventor, I'll show you. There's not a whole lot to it. Otherwise, if you don't want to mess around with MIT App Inventor, you can just download this app as it is, and it'll work fine. And also on here, we have a disconnect button. And you push that. Disconnected. And it disconnects you from the Bluetooth module connected to our Arduino board here. Then if you want to reconnect, you just go through the same procedure. Like I said, in my next video, it'll probably be today or tomorrow, I'm going to go through how you can put the module's name and address into the app, so when you open it up, it automatically connects. Alright, did I push the wrong button there? She's not coming up. She might be having trouble connecting. When you have these real close to each other, sometimes they glitch a little bit. Yep. Don't usually have this problem, you know, if you're more than a couple feet away from it, it usually won't do that. But when they're this close, for some reason, they like to glitch out a little. Oh, come on. She's being stubborn. I might have to move them apart here a little bit to get them to connect. Yeah, that's looking like what I'm going to have to do. Alright, well, you've seen it working, and like I said, it does work. And usually the only reason it does this is because they are so close. If I moved them apart, you wouldn't have that problem. So I'm not going to wait for that. We'll do next, let's go over to the computer and we'll look at the Arduino sketch first, and that's actually super simple. And also, if you don't want to type that in, you can go to the website and download that as well. And otherwise, you can look at my example and just make your own, customize it any way you want. All right, well, I'll see you over at the computer in just a moment. Okay, I have the app, or excuse me, I have the Arduino sketch opened up here. And as you can see, this is super stupid simple. This is the whole sketch right here, just these few lines. That's all it takes to do this. And like I said, if you don't want to type this in to your Arduino IDE yourself, you can just copy it off the website and paste it in. But let's go over it quick here. First, we're defining which pin our relay's on. So I'm using pin 5. If you want to use a different pin on your Arduino board, go ahead. Just make sure you change that right there to whatever pin you put it on. Next, we're going into the void setup, and we're doing the serial.begin, and I'm just running the 9600, which is standard. Then I'm putting the pin mode for the relay as an output, of course. Then we're checking if serial is available, and it's greater or equal than 2. Then we're running through. Don't mess with this right here. The Arduino is receiving a 1-byte number, but the app is sending a 2-byte number. And what this little formula here is for is to convert those two 1-byte numbers into the 2-byte number that you sent. Now next we move down. If the value, and that's being made right here by that little formula, if the value equals the code that we have in our app, and you can change the code in the app. And I just put 2222 for the demonstration. When I hook this up to my garage, if you're thinking you're going to come over here and use 2222 to open it, no, you can actually run a greater number than this. I'm trying to remember what the maximum limit is on a 2-byte number, but it's pretty high. And I'll be running probably like a 6-digit number or something like that, just something random. And you can change this in both the Arduino Sketch and the MIT App Inventor. Just make sure the numbers you choose match. Now next, if that value equals that number that we're sending, it will digital write the relay high. Then we're opening it, or leaving it open for 250 milliseconds, which is a quarter of a second. And then we're digitally writing the relay low. And done. That's it. All right. Next, let's go over to MIT App Inventor 2 and take a look at the program for your Android device. See you there in just a moment. Okay, I have MIT App Inventor 2 opened up. Now, if you've never used this before, I will have a link on the website on where to go to use this. It is completely free. There is an online version, and if you do a little Google research, there is a way to set MIT App Inventor up to use it offline as well. It's kind of to do with it running a virtual server, and I actually have that running so I don't have to be connected to the internet when I use this. But I've got it brought up here, and like I said before, if you don't want to go through and mess with this, you can just download it. And I also have the AIA file, which is the modifiable file. The APK is the finished app itself. The AIA file is one that you can open up and change. And the reason I'll be putting that on there is because you probably don't want to use 2222 as your code to open and close the door. And I'll show you in a few moments here how to change that. But first we'll go over what the screen looks like, and then we'll go into the blocks and show you how the program itself runs. Now, this is how it looks when you open the app. I have it set up, and I'm using virtual screens. Instead of having a connect and disconnect always showing, I have the big connect button. When you push that, it disappears after it connects, and then it puts your garage door control button on here, and then it has a smaller disconnect button down here. And also, like I said, I am going to be showing here in my next, either the next or the one after that video, on how to automatically connect, where you can just get rid of all this. Since, you know, once you program everything, get it all set up, you don't need to have to go in and manually connect all the time. So, all right, well, let's just get into how this app is put together. Well, we have this, so what I'm going to do is I'm going to click on Hidden Components, and these are hidden because we haven't connected yet. And there you can see I have the door button, and down there, hold on a second, where is that on here? Oh, I gotta go to screen 1, and I need to switch it temporarily to scrollable so that I can show you. There we go. I can show you everything that's on here. There's our door control and our disconnect. And then we have a label in here that just acts as a spacer. There's actually no text in it at all. And that's all there is to that. If you've used MIT App Inventor 2 before, you'll be able to modify this, make your own custom button and background and stuff like that. But I'm just gonna give you the basic run through on how it works. So once you have all that in there, or if you're just going to be modifying this, leaving it as it is, then we go over and click on our blocks. Then first we got our list picker, and that's how we connect to the Bluetooth device. And we have a before and then we have an after picking. The before is when you click the list picker button, it brings up a list of our Bluetooth client addresses and names. After you pick that, it goes through and connects to that selection, that address, that Bluetooth device that you picked. Now another thing before I forget, I'm going to be doing a video too on how to rename your Bluetooth modules. It is just a little simple program to run on your Arduino, and it allows you to change the name. You can't change the actual address, but you can change the name. So if you have multiple Bluetooth devices and they come up in that list, you know which one to select. Now next, what we have here is an if statement. If the Bluetooth client does connect and is connected, we use the text-to-speech little block here, and we just have it say connected. And you heard in the beginning of the video when I connected, the app actually said connected. Then what we're doing is we're setting that list picker, which was our connect button, to false, so it disappears. Then we're setting our button, which controls the door, to true. Then we're setting that spacer to true, and that just puts a space between the door button and the disconnect button. And then of course we're making the disconnect button true. Well, I got them two back. This is the disconnect and this is the door, but the door button's actually above that. When I was writing the code, it just got stuck in that way. It doesn't matter which order they're in, it'll work fine. Alright, let's scroll down here. Now, when we click button 1, and this is the disconnect button, it calls the text-to-speech, says disconnects, and of course it disconnects from the Bluetooth. It calls the Bluetooth client and disconnects, and then it sets the list picker to where if you want to reconnect to true, and then it sets the disconnect and the control button to false and that spacer between them to false. Pretty easy, isn't it? Now this is the one, if you're just going to use this app as is, this is the only one you got to worry about here. When the door button is clicked, we call the Bluetooth client and we're sending the 2-byte number. Remember I talked about that just a minute or two ago, and we were looking at the Arduino sketch. So we're sending the 2-byte number, and the Arduino is going to receive it as a 1. That's what we had that formula for. So this is where you just click in there, and it'll highlight it, and you can put in whatever number you want. That number there I just put in might actually be a little too big. That number there would probably work fine. But I'm going to put it back to 2222 because I got somebody coming over later to look at this, check it out, and want to show it to them. So I'm going to leave everything set up so I can use it as it is. But when I get the box built and put it in and install it in the garage, I will be changing that number. And I have brought this out and hooked it up temporarily and tried it. It does work. This program, the app, and Arduino Sketch, the circuit, everything works perfect. I walked out about 30-40 feet from my garage door and it still worked. The range kind of depends on where you put it, But from the garage door, the entry garage door to the garage door that I'm controlling is like 20 some feet, and then into my driveway is like another 30 feet. So I was around 40, 50 feet away from it, and it was working. And that is kind of about the range of these little Bluetooth devices, unless you add an external antenna. All right, well, I think that's everything we need to cover. If you have any questions, please leave a comment in the description below. And remember, all this information can also be found on the website. So I'd like to thank you for joining us here at the Z Hut today. Have a great day and have fun building.